Hi everyone. Recently I just watched the video about how microchips are actually made, and honestly I didn't expect it to be that interesting. I mean, we use cell phones, laptops, and any other gadgets every day, but I never really thought that about what goes on inside them, or how they are made. And after watching those videos, it turns out all our modern tech basically starts from something as simple as sand. It all starts with quartz sand, which is super pure and full of silicon dioxide. They melt and purify it until they get these perfect silicon crystals. Then they slice those crystals into super thin, shiny discs called silicon wafers. And then that's where the microchips are built. The crazy part is how clean everything has to be. The factories, or what they call clean rooms, are literally 100,000 times cleaner than an actual hospital or operating room. Like, even a speck of dust can damage or ruin a chip. So everyone working there wears those full body suits that make them look like astronauts. That alone made me realize how insanely precise and careful this whole process is. Then there's this process called photolithography, which sounds complicated, but it's basically printing circuits with light. They cover the wafer with this light-sensitive material called photoresist. It shines UV light through a mask that has circuit design on it, and the pattern gets transferred onto the water. It's like developing. It's like developing a film, but on a microscopic level. Then they wash away those exposed parts. Then it leaves the tiny blueprint for the circuit. And I thought it was cool that this process was actually invented back in the 1800s by a guy named Alphonse Poitevin, and it's still used today, just way more advanced. Now now they are using lasers and do everything at the nanometer scale. It's wild to think that something invented before electricity was common is now how we make those how we make the most high-tech chips in the world. So um so after the patterns made, they repeat the process over and over again, and adding different layers and materials until the whole circuit is built. It's like building a city. Each layer adds new roads or buildings for the electricity to move through. Then something called ion implantation, or doping. It's where they shoot special atoms called dopants into the silicon. This uh this changes how the silicon conducts electricity, basically deciding which part will act like switches or pathways. When I learned that this is how transistors are formed, and that there are like billions of them on a single chip, I started to understand that why semiconductors are such a big deal. And once those transistors are made, they have to be connected. That's where the copper wiring comes in. They carve these microscopic trenches into the wafer, fill them with copper, and then polish everything until it's perfectly flat again. Then each tiny wires, it connects billions of transistors together. It forms what we know integrated circuit. It's basically the brain of any electronic device. And another thing that stood out to me is how much effort goes into the checking every single step. So they use electron microscopes to inspect the chips that are at the atomic level, and the whole process can take around 2 months just for one batch of wafers. I think it's kind of crazy to think about that. You spend 2 months making something smaller than your like fingernail, but the tiny thing can control a whole computer. And it really shows that how much science and teamwork go into technology we usually take granted for. And then after all that, the chips are finally ready to be cut out and packaged. They use the tiny saws to slice the chips of the wafer and add silver and tin pellets to make connections, and then seal everything in a protective casing. And and that's the part they finally looks like the chips we see inside devices. And once they are done being tested, they are shipped out, ready to be used in cell phones, laptops, cars, consoles, and literally everything around us. So learning all this really changed how I see technology. I used to think a phone or a computer was just made somewhere, but now I realize that it's the result of years of research, precision, and thousands of steps done by the engineers and scientists all over the world. And what amazed me the most is the combination of science, creativity, and patience. I can see that they're not just assembling parts; they're working with light, atoms, and chemistry, and to build something that's invisible to the naked eye, but runs our entire world. I also learned how collaboration is key. No one person can make a chip. It takes global teamwork from design centers in one country to manufacturing plants in another. And even though everything happens on a microscopic level, it reminded me of something big, that small things, when done with care and precision, it can make biggest difference. So yeah, that is what I learned from watching those videos. It honestly gave me a new kind of appreciation for technology. And next time I look at my phone or my laptop, I remember that it all started with a sand, and that every tap, every click, and connection, it is powered by billions of tiny transistors that we can't even see. And I think it's amazing that humans are capable of creating from suns to circuits.